Hello there, algebra students. This is Mr. Kashi speaking. With this video, we're going to be going through the notes for our first section in Chapter 10, which is on adding and subtracting polynomials. So hopefully you've gone through your vocab terms and you've done your warm-up already on your warm-up and vocab sheet. But we'll dive right into the notes here. So just talk about what a polynomial is. It is a monomial, or the sum of two or more monomials. And polynomials, they can have special names. So let's just go through a few examples of those right here. So monomial would just mean that it is one number, a variable, or a multiplication of the two. So in this case, it would be 3 times x. That would be a monomial. What we would say that only has one term would be a monomial. Binomials have two terms separated by a plus or minus sign. So x squared minus 3x, this would have two terms, so we call it binomial. Trinomial would have 3 terms, x squared plus 6x plus 9. This is 3 monomials added together. They are not like terms because this is x squared, this is the x term, and this is the constant. So just a few more notes for your reference. They all have different names too with their degrees. So the degree of a polynomial is the sum of the exponents of all its variables. So a non-zero constant term has 0. So if the degree is 0, we call it a constant. If it's 1, we call it linear. If the degree is 2, it's quadratic, 3 cubic, 4 quartic, 5 quintic, and then after that, we just say it would be the 6th degree, the 7th degree, on down. So let's just talk about this. Standard form is written with the exponents decreasing from left to right. So x squared would be written first, then x, and then the constant. Okay, so standard form, yes, this is in standard form, the greatest degree. Okay, so if you wanted to say what degree this would be 2, and the leading coefficient would be 3. That's the number out front, that 3 out front. We call that a coefficient, and that's the leading coefficient because it's the first one. Okay, so this is written in standard form. We would say that this is a quadratic trinomial. Quadratic because it is x squared is the highest degree, and trinomial because there are 3 terms. All right, moving on just to kind of classify these a little bit more. Okay, and so once we should classify whether it is a polynomial, what its degree is, and then what we would call it. So we would say, yes, this is a polynomial. This is degree 1. Okay, this is technically a 1 in the exponent up there. We just don't write it. And then we would say this would be a monomial. I'm just going to put, there we go. Monomial. Sorry, I'm writing with a mouse, so it's going to be a little bit different. Okay, so it is a polynomial with degree 1. This next one is that is a polynomial as well. Okay, this is degree 2, and because we have 3 terms, we're going to classify that as a trinomial. Okay. Here, this looks a little bit different because we have 3 different variables in it, but that is still a polynomial. Okay, and then our degree, we have to add up all the exponents. So that p technically has a 1 in the exponent. So we have the 1 plus the 2. This would be a third degree, but there are only 2 terms, so that's what we call a binomial. Okay, so that'd be a 3rd degree binomial. All right. And here we would say yes as well, and then this would be a 2 degree binomial. Second degree, this is our biggest one right there. Okay. So moving on to the next slide here. This is just writing things in standard form. Okay, and standard form just means that it goes, the exponents decrease from left to right. So all of these, none of them have like terms, okay, but we do need to rewrite them in this order. we do need to rewrite them as the x to the third power is first, and then the x squared, and then the x, and then the constant of 12. So this is just writing it in standard form, is just reordering it so these exponents are decreasing as we go. And just kind of a reminder, this 4x, this is technically a 1 in the exponent. We just don't write the 1 in the exponent. So moving down here, if we had these, we would have to write them in standard form. So we would have to put the negative 2x to the fifth first, because that is the highest exponent. Then we'd have 3x to the third, and then we have 11x, and then we have a negative 9. Okay, so then it would be negative 2x to the fifth plus 3x to the third plus 11x plus negative 9. Or you could just put a minus 9 instead of plus a negative 9. All right, now moving on to just some visual representation. So this would be using Algebra Tiles. So if we wanted to do this problem using Algebra Tiles, we could just use these different markers. So 2x squared is the two big x squared blue squares there. And we have 4 x's, and then we have 3 negatives. So that first term is right there. And then we have a negative x squared plus 2x plus 4. And so this is what it would look like here. So we have a negative x squared plus 2x plus 4. And now what we're going to be doing is we're going to be matching them up just like we did here. Okay, and then all of these are going to be matched up, and basically they're going to cancel each other out. Okay, because a 1 minus a 1, they're all going to cancel each other out. Here we're just adding 2 more x's, and then here these two are going to cancel each other out as well. So at the end of it, we have x squared, and then there are 6 x's here in green, and then just a 1 constant left over. So we would say that this is x squared plus 6x plus 1. And I'll be going over multiple examples with Algebra Tiles the next time that you see me in class. If you're not using Algebra Tiles, if we're going to be adding or subtracting polynomials, there are 2 different ways. There's one method that is the horizontal method, okay, which it's not very popular, but if you're just thinking about matching up the x squareds, matching up the x's, matching up the constants, okay, and then adding them together, you'll be getting that. And the same thing for adding and subtracting. The only problem with subtracting is making sure that this almost gets distributed. We're subtracting 2x, we're subtracting 8x squared, we're subtracting 20, okay, and making sure that everything is lined up with their like terms. Okay, the one that's a little bit more popular is kind of like how we added in elementary school. It's just lining up all the terms like this and making sure that we're adding or subtracting. There's really no carrying or anything like this because there's nothing that we're going to get so much that we have to magically get this x. Okay, so with the variables we just add or subtract whatever's there. Okay, and so this is a second method. The vertical method is a little bit more popular. So I'm going to stick with the vertical method for now. I can go over some examples with the horizontal method when I get back in class. But so here, if we were to write, if we were to take this, write it in standard form. Okay, that's how I got this c squared minus 3c minus 22. So I'm just taking this and then writing it in standard form over here, and then also writing this second term, part of our addition equation or expression right here. So here we would just be adding c squared plus 2c squared, and then we have this negative 3c plus negative 22c, and then we have negative 22 plus a negative 12. And if we were to add those together, we have c squared plus 2c squared. That would be 3c squared. Okay, negative 3c plus negative 22c. That would give us a oh, sorry, my goodness. That'll give us a negative 25c. And negative 22 plus a negative 12, that would give us a negative 34. Oh, hold on. Taking a second look at this. Looks like we have a mistake here. This would be a positive 22c, so right here. And that would be a positive 19c then. Okay, so that isn't correct. So 3c squared plus 19c minus 34. So moving on to the next example here, we have this 2x squared minus 2x plus 9y. Okay, the big thing here is that there's a y involved. So we have y's here, and then we have this x term, but we don't have an x term here. So for the second one, I added in this 0x, which is really important to remember. Okay, and so once you add these up, each of those in their own columns, you get 6x squared minus 2x plus 5y plus 15. Then moving on down to this next one, we have, just setting it up, we have negative m squared plus m, okay? But here we don't, this second term we do not have, or the first term we don't have a constant, so I'm going to put plus 0. And then the second term there's no m, so I'm going to say this is m squared, and then I'm going to put a plus 0m plus 11. So just keep putting those zeros in, kind of helps us stay organized so we know what we're doing. We're adding these, obviously. When we add, those two cancel. So there will not be an m squared term here. M plus 0m is just going to be m, and then 0 plus 11 is going to be 11. So we have m plus 11 for our final answer. That's all I'm going to do for this video. There will be some there will be a second video going over the subtraction examples from our notes.